Hello and welcome to yet another video of Cornerstones of Math. Today we are going to find the solution to the equation 2 sine squared x squared plus x plus 1 plus cosine x squared plus x plus 1 minus 1 equals 0. But I am not just going to find a special solution in a certain interval. I am going to find the general solution. That is, all possible values of x satisfying the given equation. Let's see how we can do that. The first obvious thing to do is to notice that we have the common part x squared plus x plus 1 here and here. So we can make a substitution x squared plus x plus 1 equals t. Then the equation becomes 2 sine squared t plus cosine t minus 1 equals 0. And this 2 sine squared t can be written as 2 minus 2 cosine squared t. So this plus cosine t minus 1 equals 0. This equation only consists of cosines of t, so we can make another substitution, cosine t equals u. Then we have 2 minus 2u squared plus u minus 1 equals 0. So 2u squared minus u minus 1 equals 0. So u minus 1 times 2u plus 1 equals 0, which gives u equals 1 and negative 1 half, meaning that cosine t equals 1 or negative 1 half. And this is the part where we have to think about so-called general solution to the trigonometric equation. We can obtain the general solution using the special solution in a certain interval. Let us think about special solutions on the interval t greater than or equal to 0 and less than 2 pi. From the graph of a cosine function, we can easily find out that the special solutions are, for cosine t equals 1, we have t equals 0, and for cosine t equals negative 1 half, we have 2 pi over 3 and 4 pi over 3. The general solution can be obtained using these special solutions and the knowledge on the symmetry and periodicity of the cosine function. Getting straight to the point, the general solutions are t equals 2n pi and 2n pi plus minus 2 pi over 3, where n is integer. This seems a bit confusing at first, but if you take your time and examine these, you can find out that these indeed represent all the x-coordinates of the intersection point between the cosine graph and two lines. So if we convert this t back to x, this means that x squared plus x plus 1 is equal to 2n pi or 2n pi plus minus 2 pi over 3. So now we have to solve quadratic equations of x. As for x squared plus x plus 1 equals 2n pi, we have x squared plus x plus 1 minus 2n pi equals 0. Therefore, x equals minus 1 plus minus square root of 1 minus 4 times 1 minus 2n pi divided by 2, which gives minus 1 plus minus square root of 8n pi minus 3 divided by 2. As for x squared plus x plus 1 equals 2n pi plus minus 2 pi over 3, we have x squared plus x plus 1 minus 2n pi, and we can write plus minus 2 pi over 3 equals 0. Here, you can keep this plus minus if you want, but since we are about to use the quadratic formula, which also involves plus minus that is independent of the other one, I will just divide cases to avoid confusion. So as for x squared plus x plus 1 minus 2n pi plus 2 pi over 3 equals 0, we have x equals minus 1 plus minus square root of 1 minus 4 times, now 1 minus 2n pi plus 2 pi over 3 divided by 2, which gives minus 1 plus minus square root of 8n pi minus 8 pi over 3 minus 3 divided by 2. Here, in order to remove this fraction, let us multiply 3 on both numerator and denominator. Then we have minus 3 plus minus square root of, and if this 3 goes inside the radical, it becomes 9, so the inner part must be multiplied by 9, which equals 3 times 3. So we can write the result as 3 times, then this part multiplied by 3, which becomes 24n pi minus 8 pi minus 9. So this divided by 2 times 3, hence 6. There may be even simpler expression, but I am just gonna use this. Now for the other case, for x squared plus x plus 1 minus 2n pi minus 2 pi over 3 equals 0. The process is the same, except now we have minus sign here instead of plus sign. So in the end, we obtain minus 3 plus minus square root of 3 times 24n pi plus 8 pi minus 9 divided by 6. Now if we combine these results and write them one by one, we obtain these 6 different expressions for the general solution, with n being an integer. I used different colors on some plus and minus signs so you can recognize the difference more easily. And that's all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.